Hello. Okay, awesome. My name is Kate, and today I'm here to talk to you about automation tooling, and basically like how to stop it from ruining your life. Or maybe like if that's too ambitious, I will just say your job. So the punchline was given away a bit because I'm from Australia. So I'm going to be doing my best in this talk to like enunciate my words as best that I can so that you can all understand me because there will be no subtitles while I'm talking. So I'm not going to like yab on about how I'd rather just go aggro, chuck a Yui on this lappy prezzo, put me trackies on and trot down to the bottle for the Arvo to spend some hard-earned dollary doos on a few bevies. That works. Thank you. No, jokes aside, no subtitles, so please bear with me. So now, luckily for you, this presentation is not like just about bad Australia jokes, because I do actually have a day job, and that is as a technical team lead at a startup called GreenSync. There we get to do like lots of fun things with renewable energy and batteries to make ways of like making green and distributed energy sources of energy. Oh gosh, it's like a tongue twister, this whole thing. Monitorable, scalable, and sustainable. But it's like a startup, we're a pretty small company, right? So like we've only got 20 engineers. So suffice to say that the tooling hasn't really had a chance to like go rampant. So where did all the content for this talk come from then? Well, my background is actually primarily as a software developer specialising in Ruby. And several years ago, up until fairly recently, I found myself working as a Ruby dev in this pretty big company in Australia called REA. There we built this website, realestate.com.au, which is a property portal site similar to like Zillow or Realtor here in the States. But during my time there, I became like more and more interested in systems engineering and delivery in general. So I made the move into what we called a delivery engineering team at REA. So this team was responsible for helping like all of the other engineers at REA find good ways to build, develop, package and deploy their applications. And we did that through like a number of ways. Firstly, we built tooling for other people to use, yay, which is why you're here. But we also like gave guidance to people and ran training sessions as well. So a lot of the stories in this talk have come out of my experience during that time. So the first question we have to address in order for this talk to like make any sense whatsoever is what actually is automation tooling? Well, these are just like pieces of software that are there to automate some part of the software development and delivery process. In other words, they're like transforming those steps that would otherwise be manual into ones that are automatic. So you might find these tools in the wild performing steps like setting up your development environment, maintaining a build pipeline for your application, or deploying your application to your chosen platform. The tools themselves vary a lot. So they can be like as simple as a script or as complex as almost offering a platform as a service. I kind of like to think of them as like the Lego blocks that can be clicked together to form a common base between all of your different systems. So that all sounds good, but like obviously building this tooling takes a lot of time and effort. And like you might be wondering what would prompt a company to invest so heavily in building it. Well, at REA, and I think at many other companies too, the truth is that we just kind of had to. And it really came down to one thing, and that is growth. So the number of engineers at REA had been growing really, really rapidly. And in addition, this rapid growth had pushed us into embracing microservices. So this meant that on top of having our systems developed on by like a vastly larger number of people, we also just ended up with a vastly larger number of systems. So we ended up facing like the same engineering issues like how can I set up my development environment and how can I deploy my application, just way more often than we once were. And existing solutions that were kind of working before, like maybe you had really good docs on setting up your dev environment or having like that person in your team who can kind of run through every deployment with you, well, that just was not scaling at all. So if we look at the actual numbers during my time at REA, we had about 620 engineers, and they were covering like 580 systems. So it really it doesn't take a mathematician or like a 12-year-old to realize that that's one system for every engineer, basically. And a lot of those systems were deployed into multiple environments as well. So without some sort of tooling, maintaining this ratio would have been completely impossible. So while it has been a really big investment, I think that the benefits that I've seen from implementing automation tooling has really outweighed the cost of building it. Firstly, achieving like one-step tests, one-step builds, one-step deploys means that there is no margin for error in these processes. And what this actually like translates to is that the people working on these systems are just far more confident in the delivery process and like how long it's going to take them to get something released. Providing automated solutions to common problems also means that like every team doesn't have to re-solve the exact same problem multiple times, and developers can spend more time developing. You can also build tools that are like as framework and language agnostic as possible, making it much easier for engineers to move between different projects. In my experience, this has been like especially helpful if you are trying to increase the amount of engineers who are able to support their own systems. As for instance, like learning one deployment tool can give you the knowledge to deploy hundreds of different systems. Okay, so now we have learnt like a few things about automation tooling. Firstly, we know it's software, which is good. Like, I think everyone in this room has just stacks and stacks of knowledge about building and supporting software, so there shouldn't be a lot of surprises there. Secondly, we know that like building out this tooling and automating your processes is helpful and often necessary, particularly if you're growing your engineering force. And finally, we know that building out this tooling can end up kind of reducing the overall effort of deploying all of your different systems. So, right about now you might be thinking like, great, I guess we just go get a coffee for the rest of this talk, right? Like, my point here is that we should just automate more things and then win at life. But unfortunately, like, that's not quite true, and in my experience, like, nothing in software engineering ever ends up being that simple. So now we have to ask the question of like, what can go wrong when you start automating these processes and building out the tooling to do it? For me, like, we never had any huge incidents where like everything was on fire and suddenly everyone just realized the tooling sucked. It was like a gradual recognition. So one of those things that develops with hindsight, and it didn't dawn on everyone all at once either. So what happened was like after we invested in building out this tooling, the business ended up in this state where like things were still being delivered and there were a lot less manual processes. But at the same time, heaps of new bottlenecks had been introduced, and in a lot of times like these slowed down delivery and made it just as time consuming to get things delivered as before the process had been automated. Plus like these big knowledge silos had been introduced and we had a bunch of brand new tech debt. So how could we have prevented this from happening? And where had it all gone wrong? Well, unfortunately, I think a lot of these tools went wrong at the very, very beginning, which is just the worst place something can go wrong, right? And the reason they went wrong is simple though, right? We are engineers and the purpose of our jobs is to problem solve and build solutions to the problems that we see. What we really needed to do was build products and build these products rather than just focusing on building solutions. Because in order for your tool to get adopted and be successful, it really needs to be like compelling and easy to use and customer focused, where like your customers are your fellow engineers. And it needs to be marketed to these people as well. When no one asks like what a tool is meant to achieve before they start to build it, trust me, you will inevitably end up with some sort of like Frankenstein tooling that might offer like lots of different ways to accomplish the same thing, be like difficult to update, difficult to understand, and will probably only be used by a select group of people, and that is most likely just the people who are actually maintaining that tool. So I hope from this talk that you'll be able to get an idea of why it's important not to just like invest in building out your tooling and automating your processes, but like invest the time in planning out this tooling so you know you're building the right kind of tool for the right kind of job. And to help you make that decision and ensure that you build the right type of product, I'm going to show you 3 main patterns for writing automation tooling that I have seen during my time. So we're going to have a look at each one of these patterns, take a look at a good use of the pattern, have a look at a scenario where using this pattern just did not work out at all. And then from those examples, decide like when you should use each one and what problems they can be used to solve. So the first pattern that we're going to look at is called the Swiss Army knife. So this is a tool that combines multiple individual functions behind a single simple interface to provide you with like a kind of one-stop shop for your development or delivery process. Now, a great example of this is Kubernetes. I think everyone here probably knows what Kubernetes is, and like it's been drilled into you over the last day and a half. But just in case that's not the case, I can give you like the website spiel, which is that Kubernetes is an open source product for managing, deploying, and maintaining containerized applications. So let's say I have my containerized application, Hello World, and I want to deploy it. Well, I can just run a single task. kubectl run hello world image hello world, and we're done. I've now got my application deployed. But that was almost like too easy, right? So let's try something a little more complicated. Let's say my application has become really popular, so heaps of people are using it. I need to scale it up. Again, I can just run a single command, kubectl scale deployment hello world replicas 4, and we're done. So I've got 4 of my applications deployed now. So if we think about those commands, what about them makes Kubernetes a Swiss Army knife tool? Well, firstly, I was able to perform my task, in this case, both deploying and scaling my application with the minimal amount of knowledge. Now, because these tools focus on providing like a really simple interface, they're inevitably very opinionated. So like here, I didn't need to know anything about where my application was being deployed or like write a massive configuration file. I just defined the things that I was interested in, and here that's really just like what the hell my application is, and assume that the tool is making all of those other decisions for me. And finally, the amount of decisions that Kubernetes has to make in order to deploy this application is really a lot. So it's doing things like orchestrating that deployment across multiple servers, managing resources like CPU and memory, monitoring my application to make sure it's like healthy and running, and networking to that app to make sure requests can get there. And while I thoroughly encourage everyone to go out and use Kubernetes, building your own Swiss Army knife tool is really the most risky type of tooling that you can invest in building. And that's not really surprising, like because they're pulling together all these different bits of functionality, they're just more likely to be a bigger investment upfront to implement. That, plus because these tools are often designed to kind of solve your whole delivery problem, like they're not just focused on one thing, they really easily experience scope creep. Especially when the product has just no clear vision or clear boundaries to begin with. So today, I'm going to tell you a story of one of the times that I have seen one of these Swiss Army knife tools lose its way. So this tool was built at REA just after we had unveiled a company-wide directive to begin moving all of our services out of our existing data center and into Amazon Web Services. And to accomplish this, like the word DevOps was being sprinkled around as this like magical tool that was going to make this migration happen. So as is wont to happen when DevOps starts being mentioned, systems engineers started being embedded in teams rather than being centralized, which was pretty good, but we kind of hadn't worked out how this developer-ops relationship thing would work yet. So what we ended up with was actually like a small group of developers being supported by just a couple of systems engineers. It was kind of like a distributed, centralized ops model. But this didn't go so well at the beginning. Like remember, REA is a company with basically one system per engineer. So while these ops were only trying to support a few different development teams, they were actually supporting like 30 different Snowflake applications, which at this time were really inconsistently deployed and maintained. And these systems engineers needed to do more than just support these applications. They needed to somehow upskill all those developers at the same time so that they could begin migrating them into AWS. So I'll give you one guess at what they did to make this work. Yeah, they made tooling. So the tool was built that did a lot of good things. It simplified the underlying configuration format, which was like these huge blobs of AWS CloudFormation JSON, and transformed them into a much simplified YAML format with a bunch of common configuration options extracted out. It also simplified the CLI a lot and enabled engineers to easily deploy, update, and troubleshoot issues with their systems. So all of this, I guess, just really empowered the engineers to start managing their own infrastructure. So it was a great first step at encouraging that DevOps culture to grow. But building this tool also came with some problems. Like, it was basically a full-time job for one of those two systems engineers, which meant that they didn't end up having like any time whatsoever to spend with the developers to help upskill them. Plus, this systems engineer suddenly became the gatekeeper for any changes that needed to be made to the deployment process. So engineers often just became stuck, waiting for changes to be made to this tooling before they could proceed with deploying or migrating a new application. And on top of this, the tools started to grow organically. So it really wasn't too long at all before the configuration for a single deploy could also provide configuration and commands for SSHing into instances. It could communicate with monitoring and alerting systems. And in this case, that was PagerDuty and Stackdriver and New Relic at the same time to set downtime and manage alerts both during and in between deployments. It gained some extra skills for managing already deployed apps as well and could manually set the number of active instances and pause and resume any scheduled actions. It even added some extra functions to help people migrate out of our data center by talking to a centralized load balancer that was deployed there. So talking to that load balancer, it could enable and disable servers and switch DNS traffic. So suffice to say, developers became really, really reliant on this tool. It had enabled them to do what they hadn't been able to do before by giving them control and confidence over their infrastructure management. And for a while, it worked really well. But then the absolute unthinkable happened in this situation. The systems engineer writing this tool, they left. And with them, they left this massive crater of knowledge about this tool that had somehow ended up controlling the entire deployment and maintenance for a lot of applications. And on top of that, while we've been looking at this picture here, where we have our couple of systems engineers building a tool for these few development teams, the whole of REA actually looked like this. And all of these other teams hadn't even heard of this tool, let alone tried using it for their own applications. So this is basically the story of how this tooling became legacy. And it's really a story of what has struck me the most about building tooling for other people to use. So you can't just write something good or even write something really, really great and expect that to just be enough to make it a success. You really need to work to get buy-in and to get people using it and to advertise it as an awesome thing that everyone else should be using. Building the tool itself ends up being a tiny, tiny portion of automating your processes and kind of gaining consistency in delivery across your different systems. So with that in mind, when should you actually be building a Swiss Army knife tool? What does this kind of tooling make sense for? Well, it's optimized for one thing, and that is speed. So this type of tooling is designed to enable developers to perform their task as quickly as possible without having to make too many decisions that might slow them down. They're simple and intuitive to use, which means that engineers won't have to invest lots of time in actually learning how to use them. However, the things that make these tools so good are also what makes them so difficult. Because engineers, engineers are smart and they generally have lots and lots of opinions. So it's not surprising that they might not agree with the mandates that your tool is imposing, right? Because of this, it can be really difficult to get people to actually use this type of tooling. So how do you avoid that? How do you make sure this tooling is actually adopted? Well, there are two things that you are really going to have to invest in. Firstly, you're going to have to make this tool so obvious and easy to use that there is just no good reason for someone not to use it. And secondly, you're going to have to just provide amazing support. So any problems that people encounter can be solved quickly. And engineers don't find their work blocked waiting for your tooling to work with their system. So really, if you're planning on building this type of tooling or even just using this type of tooling, you need to plan to dedicate a team to it because it's just going to take a lot of time and effort to build it right and then a lot more time and effort to support it. So we've made it to the second tool now. This one is called the screwdriver, and it focuses on solving just a single problem, so it's really small in scope. Now, for an example of this, we're going to have a look at an application deployment tool written in Ruby that some of you may be familiar with, which is Capistrano. So Capistrano does one thing. Its goal is to provide you with repeatable deployments of your applications. It's really like a muggle of a tool in that it has a strong philosophy of no magic. Did anyone get it? Yes. Hello, Harry Potter fans. But what it does do is provide you with a way to kind of define and automate your manual steps. So for those of you who haven't used Capistrano before, let's take a look at what one of these deployments would look like. Well, Capistrano works off configuration, so we have to get dug into some files. Now, this is only a small snippet of the configuration that you would actually need to deploy an application. Like a full configuration would not fit on a slide. But already you can see, like, this is way more verbose than what we saw with Kubernetes. Now, some of the options in this top file are going to be really simple for me to configure, like set app name, my app, set repo URL, like I know what my application is and where it lives on Git, that's easy. But this second file starts to get a lot more complex. So there's like this concept of syntax, and I can choose either server-based or role-based, and there's some custom SSH configuration in there as well. So what this tells me is that when I use Capistrano, there's kind of an expectation, right? That I'm going to have to make some decisions about the what, where, and how of deploying my application. And then I'm going to have to further translate those decisions into the language of Capistrano. So, thinking about that configuration, what makes Capistrano a screwdriver tool? Well, firstly, it's focused on doing one thing, which is providing you with a way to run your manual deployment steps on a remote host. It's only making decisions on how to structure that deployment configuration within that repo and how to connect to your remote server. It's also not making any decisions about how you actually want to configure and run your application. And you can see that in the amount of configuration required. So it's pushing those decisions down onto the developers. Now, sadly, I was actually the main perpetrator behind building a screwdriver tool that definitely did not live up to the fame and value that Capistrano has delivered. It ended up being a complete waste of time. So I give anyone full license to come up to me after this talk and tell me that I'm a terrible engineer. I won't hate you at all. But I'm putting all the cards on the table with this one. So this tool was concerned with a central business critical database. This database was basically the crown jewels of the business. And we were responsible for migrating it out of our existing data center and into AWS, which really seemed like a simple enough task to us at the time. So we just started building a test database. So we wrote a configuration template, and then we had to run a few manual steps as well to do things like import time zone information and create the appropriate users. And after that, we had a brand new database set up and ready to run some performance tests against. But it had actually taken us quite a long time to get this database up and running. And there had been those several manual steps involved. Plus, during the process, we realized that there were a few more databases that needed to be migrated other than just this one production cluster. So there was also one in a staging environment. And then there was one in a shared development environment as well. But then, to our surprise, we found out that there were a bunch of database replicas lying around that different areas of the business had set up for their own purposes. So now that there were several databases involved, we had a few issues. Firstly, we were going to have to repeat that ordeal of creating a new database multiple times. Secondly, we really wanted a way to make sure that every database was being deployed with the same base infrastructure configuration. And finally, we wanted to reduce the manual work we had to do by filling out that configuration file and running those extra manual import steps. So me and my team decided to build a small tool to solve these issues, which we really creatively called Database Deployer. So this is the point where this story starts to go downhill, and you'll notice it is also the very beginning of this tooling being built. Because unfortunately, with my background as a software developer, I have a really bad tendency to just way over polished turds in an effort to make them look pretty and attractive. So it wasn't long before this tool was a fully optimized Ruby application, complete with an object-oriented design and clean, maintainable, readable code, a full test suite, a really comprehensive CLI, and then support for features we didn't even need at the time, like multiple database engines and parameters, as well as configuration for flexible alerting strategies and custom security rules. So with all these features, it ended up taking us well over a month to build this tool. And what did it give us in the end? Well, we had, at the very least, solved our initial list of problems. So the number of human steps required to deploy each database was reduced to just one. And we were releasing Database Deployer as a version tool, so it was much easier to see what template each database had been deployed with. Plus, our tool used YAML instead of JSON for configuration, so we were like much happier using it. However, because we didn't think of Database Deployer as a product when we planned on building it, we really ended up building something that was just not what we needed at all. Firstly, it was not opinionated enough. Like, by making almost everything configurable and then adding those extra configuration options that weren't even needed at the time, we just doubled the amount of work we had to do. Like, the building of this tool itself took longer, and then like every time we needed to deploy a new database, it took twice as long because there was twice as much configuration. And while our intentions for making this tool this flexible were really good, like we thought that by introducing flexibility, we would make it kind of more applicable for the rest of the business, in reality, this just ended up making it more complex and less likely to be used by anyone. Secondly, because this tool provided kind of so little additional functionality compared to just using the underlying Amazon service, it just wasn't compelling enough to get other people to use it. Like, for external teams, the overhead of having to learn a whole new tool set would not have been made up for by the functionality that it provided. Now, does this list mean that we shouldn't have built a tool at all? No, like not at all. But I really think that if we had thought about it as a product beforehand and thought about where it was going to be used and what value this tool actually needed to add, we would have made it a lot smaller in scope and focused on just solving the problem of making our database, rather than all of the possible databases in the world, simple for us to deploy to Amazon. So oh, sorry, I skipped ahead there, didn't I? So when should you introduce Screwdriver tooling to your work? I've given it away. I would recommend it if you want to encourage innovation. And when I talk about innovation, I don't mean like coming up with awesome new product ideas. Like, I couldn't really give a shit about products. I'm talking about enabling teams to take control of their own technical decisions, right? So that they can move fast and like experiment with new tools or languages or frameworks. Screwdriver tools work really well in these scenarios because they're pushing a lot of decisions down onto the developers, so they're generally more flexible and able to be used in a wider variety of situations. Because they focus on such a small scope of functionality as well and don't make many assumptions, they're generally a lot easier for engineers to understand like the mechanics of what the tool is doing. On the other hand, what are some of the issues you might encounter with Screwdriver tooling? Well, because your tool is like much less opinionated, you're effectively passing the responsibility down to the engineer to solve for every system. This can result in lots of wasted effort, as like the same configuration work has to be carried out by multiple engineers across multiple systems. This can also cause a lot of variance between your systems in how the same automated step works, even though they're all using the same tool, just because of that difference in configuration. And finally, these tools are going to require a certain amount of knowledge from the engineers who are using them, as they're going to be responsible for making all of those important decisions that the tool isn't making. So we've reached the final tooling pattern. This one is called the duct tape tool. And it wraps an existing system to create a consistent interface and reduce friction. So for an example of this, we're going to have a look at an application that's used to create a consistent interface over multiple applications. And that tool is normalized scripts. So normalized scripts is actually a term that I have stolen from GitHub, because they have documented their use of this pattern in the GitHub scripts to rule them all repo. Now, the concept behind these scripts is pretty simple. Each one is a small independent script that has like a consistent or normalized name that performs the same tasks, so has the same responsibility over multiple repositories. Simple, right? So to really understand what I'm talking about, we can have a look at one of the scripts that GitHub provide in their repo. So this one is called test, and it's an example of running the test suite for a Ruby application. As you can see, like the script itself is really not very complicated or detailed at all. Like, it's got 2 if blocks. This is the whole thing. The top if block is just doing some required setup, and then the second if block calls the test method of rake, which is, as I said before, Ruby's make-like program. So yeah, like this script by itself, right, provides no value whatsoever. But the point is that you would have a matching test script in every single one of your application repos, no matter what language or framework that application is using. And this script would have the same name, so it would also be called test, and it would perform the same responsibility. So in this way, the test scripts would provide a single consistent interface for running the tests across all of your different applications. So how are these scripts an example of duct tape tooling? Well, firstly, they're providing a consistent experience for interacting with a code base. By using this pattern, you can reduce the friction and speed up the setup time for engineers working on your projects, as they can be familiar with how to work with them straight away. They're also really easy to learn, as they're responsible for only a single unit of work. And on top of that, when someone learns the responsibility of a script, that knowledge can be transferred and applied to every single repo following the same pattern. And finally, they are really painless to implement. This is because they can be wrapped around any application whatsoever, as they have no mandates about how the application itself should behave. Like, honestly, if you're in a company with kind of more than a handful of systems, I really, really recommend giving this pattern a go across your own repositories. It is such a small change to make, but I have honestly seen it make such a difference to improving people's confidence and willingness to contribute to new projects. Like, it's not enough to just say, make a pull request. If you have this, it will work. But again, duct tape tooling can definitely do more harm than good if it's used for the wrong reasons. So about 4 years ago, I was in a team and we were the custodians of this super monolithic Rails application. So there were like 3 main problems with this app that were causing us lots of strife at the time. Firstly, it was a Rails application, so enough said. And secondly, getting a development environment set up for this tool, app had become really, really painful. Like, when I first joined this team, I had it up and running in a day. People were surprised. It just took hours to get this thing up and running. And finally, lots and lots of developers from all across the business needed to make changes to it very frequently. So we had to help out. Like, every time a new person came along and they needed to set up their environment and run the tests, even if the change they actually wanted to make was as small as just fixing up some copy. So our solution to this was to use Docker to package and run the application in development and CI. Using Docker, we knew that we could achieve our goal of having a one-step process for setting up a development environment. But there was a big problem with this. So 4 years ago, and Docker was pretty new, this meant that only a handful of people who were contributing to this project had ever heard about Docker, let alone tried using it in their own systems. So we came up with a solution to this problem as well. And this is it. It's not pretty. This is a bash script that lived in the root directory of our project. And if you look in the bottom left-hand corner, you'll see that it's called bundle. Now, for the non-Ruby developers out there, bundle is actually a Ruby tool for managing application dependencies. And the kind of bundle command is used as a wrapper for all of your other Ruby application commands. So for example, you could run the command bundle exec rake to run rake and have all of your dependencies loaded in at the same time. Now, back to the script. If we have a look on the last line of this script, you might notice that it's calling bundle from within a Docker container with the application installed and configured on it. So for an example of how this script would work, developers could run the exact same command as before, so bundle exec rake. But who can guess what would happen if they ran it in the root directory of this project? Yeah, it would run from within a Docker container and not from their local environment. So this script was actually just wrapping Docker in order to enable the developers to use the technology transparently without having to kind of learn too much about how Docker works or change their current development patterns. And unfortunately, that goal of not having to kind of force people to learn how to use Docker is exactly why this tooling was a failure. Because it made it much harder for engineers to understand what was going wrong when their bundle commands failed. Because without reading that bundle script, right, there was no way to know how Docker was being used or even if it was being used at all. So we really ended up having to invest like basically the same amount of time supporting people with their mysterious bundle command issues as we had before with setting up their development environment without Docker. So we also really underestimated our developers' desire and capacity to learn a new technology. Like, this script became obsolete so quick, it was like lightning. As soon as the majority of engineers at REA gained more knowledge about Docker, it really became more of a burden than a help because it obscured what was really going on. We really should have invested our time instead into teaching and training people how to use Docker rather than kind of trying to make their learning someone else's responsibility by writing this piece of duct tape tooling. So considering that, what should your motivation be then for writing this type of tooling? Well, I would recommend it if you want to improve the agility of your teams. This is because they can reduce the friction or overhead of having to make changes. On top of this, they're really small and have almost no business logic, so they're generally simple and fast to implement. But the issues that you'll run into with this type of tooling is firstly, it can become obsolete very quickly. So you should either plan for this tool to be a temporary fix or be prepared to update it frequently, as whenever that system that you're wrapping changes, you're probably going to have to change your wrapper as well. And finally, the value that this tooling provides can be very questionable at times. So you really just need to ask yourself, like, is the tool that you're writing actually going to help people, or is it just obfuscating the service that's underneath it? So that was it, the final tooling pattern. So now that everyone's got 3 patterns under your belt, let's do like a recap to see where they all fit in. Firstly, we looked at the Swiss Army knife tool that combined multiple individual functions behind a single simple interface, which can help you with speeding up your development and delivery processes. Secondly, we had the screwdriver tool that focuses on solving just a single pattern that can encourage innovation in your teams. And finally, we had the duct tape tool that wraps an existing system to create a consistent interface, which can improve the agility of your systems or engineers. But as we saw before, all of these tools have some drawbacks, right? So the Swiss Army knife and the screwdriver are going to require more support, while the screwdriver and the duct tape require a higher amount of knowledge and proficiency from the people who are using them. And finally, the duct tape and the Swiss Army knife tool are less flexible. So they really can't be used for much more than they were originally designed for. So now, hopefully, the next time you're facing a roadblock with building or delivering your software, don't just go to the pub and try and forget all about it. I've been there, it sucks. So think back to this talk and think about what is kind of driving the issue you're facing. Is it caused by slowness, an inability to innovate, or a lack of agility? So think about those problems and then find a way to automate around it. And then you can go to the pub with a clear conscience. So if there is one thing that you should take away from this talk, it is this. Automate more things, it's fucking awesome, but please plan it first. So thank you.